everybody who is watching this video. My name is Sir Olenjolai Moko TAYAI Losingo, just simply me call Sir Olenjolai, from beautiful country that's called Tanzania, east on the African continent. I'm very happy to have you today, and I would like to welcome you into this fantastic moment of learning the beauty of higher engineering and scientific mathematics. So before we start today's session, I would like to spend a few minutes just to give you a little bit introduction, because possibly you have joined me today, and I'm very happy to have you and stay connected, because there is the good news that I have for you that will transform your life from the point where you are to the next point. So I would like today's opportunity to welcome all international and national viewers into our online undergraduate Polytechnic Institute of Tanzania in square bracket OLENJOLAIM. Because I'm teaching engineering mathematics, I'm teaching mathematics, basic mathematics, advanced mathematics, basic applied mathematics, basic engineering mathematics, basic scientific mathematics. I'm also teaching higher engineering mathematics and higher scientific mathematics. I would like to welcome you simultaneously into one of our YouTube channels that's called Online Undergrad Institute of Tanzania in square bracket OLENJOLAIM. So you have so many questions. Possibly this is your first time to join us. So we are very happy to have you today and welcome you, and really ask you that stay connected, because we have a good news in every session that we are going to conduct, because every session or every lecture that we are going to teach you, it's an event, and will make you to love the subject of mathematics, or the module of mathematics, or the course of mathematics for the rest of your life. So you're not just like entertaining you, or just lying around the corner and moving your mind. What we are telling you actually that we are going to try our level best to make sure that we reach your demand, or we reach your requirements, we reach what you are thinking for, or you are longing for. So you have so many questions, but one of the common questions that you might be asking yourself, what visions we have in Online Undergraduate Polytechnic Institute of Tanzania square bracket OLENJOLAIM. Well, that's a good questions, and according to the book of Proverbs chapter 29 verse 18, it says that where there is no vision, people perish. So where there is no vision in Online Undergraduate Polytechnic Institute of Tanzania square bracket OLENJOLAIM, Olenjolai and his students are going to perish, and we are not ready to perish. That's why that we want to declare and be reminding you every time, because that's what has been written in our mind. We don't give up, and even that we are not discouraged with the daily challenges that we are facing when we are trying to push these programs, which we call it generational programs, because it is going to help the present generation and even the future generations extraordinary, because these contents are going to supplement and simplify your process of learning. So this division, it's an assignment that we have been given by our Father who is in heaven. We have an assignment to teach, train, incubate, mentor, lead, and even motivate, just encourage some group of students who will be ready to extract the knowledge and wisdom from the formal or informal educations that you are learning in the classroom, that we call the classroom education. And also we are going to teach you to extract the knowledge and wisdom from the Word of God written in the Holy Bible, and combine these two knowledge and wisdoms in order to solve real life problems. So our main objective is not actually that to help you for your continuous assessment. Our main objective is not to help you to pass your final exams or your university exams. Our main objective in Online Undergraduate Polytechnic Institute of Tanzania is actually to see our continuing and graduate students are solving real life problems, even if a small scale real life problems for us is worth. I know what I'm telling you right now, it's blowing your mind, and possibly you might be on the side that it's impossible to realize what I'm telling you right now. But I want to tell you that we are going to try our level best to make it possible, because myself, I'm an example of what I'm telling you. So I'm a product of what I'm telling you, because our visions has 4 parts: extract knowledge and wisdom from the formal and informal education, extract knowledge and wisdom from the Word of God, and then combine these two knowledge and wisdoms and solve real life problems. So myself, what I'm doing right now, I'm solving a real life problem. So because I'm solving a real life problems, I'm not solving the real life problems because I have a good sense or I'm very intelligent. No, because I combine these two knowledge, which I'm telling you that we are going to teach you to extract it, and wisdoms. So I'm solving a national problem right now, but later on I'll expand my coverage or my dominions into the continental level and even international level, intercontinental level and beyond the continental level, because we are not limited because we have a digital technology. So we have so the main objective of these platforms, remember that we want to see you are solving a real life problem. So you are preparing yourself to solve a particular real life problems in your community, because that's why that we are educating. Again, we have so many specific objectives. One of the specific objectives when you join into online undergraduate Polytechnic Institute of Tanzania, OLENJOLAIM, we are going to help you to go through your continuing assessment as well as you can. And also, another specific objective, we are going to prepare you to get well prepared for your final exams or university exam. And also, another specific objective, we are going to transform you to restore your love of higher engineering mathematics and higher scientific mathematics. So another specific objective that also will make you to master this subject and think differently, and even we are going to teach you to think differently from the perspective of mathematics or engineering mathematics, and we think we'll teach you that how you can use these informations on solving real life problems or on the real application. So that's the piece of information. We have so many to tell you, just stay connected, and then we are going to give a piece of information in every session. So also, before I just take you into what I've written on the blackboard, I would like just to remind you that there's a few steps that you have to follow on joining with online undergraduate Polytechnic Institute of Tanzania, (OLENJOLAIM). Those procedures you just spend a minute, because if you have an email, you just have to click the buttons which has been written here on the right side of your video that has been written subscribe. Okay, subscribe. So hit this button, because what the meaning of subscribe from the English dictionary, it means that arranging to get information for the new products, or for the release of the new product. So when you hit these buttons of subscribe, once we upload, because we are going to create a level best to upload at least a single video every day, at least one video every day in online undergraduate Polytechnic Institute of Tanzania. So hit these buttons, and then once you hit these buttons, then the buttons of the bell will appear. Click it. So when I say hit, it means click this button. Then you find color will change, and it will be written subscribe, okay, in another color, and the background is going also to change, become white. So when this bell appear, also click it. Then you have to choose the options of all. So it means that once we add any new video, whether during the midnight or during the early in the mornings or during the midday, then you'll be the first one to get notifications once you'll be online. Okay, so that's another point. Another thing, we have also an online library. So in this online library, we have materials that can support you on learning in higher engineering mathematics and higher scientific mathematics. One of the weapons that we will need it from now onwards, or in every sessions, is a scientific calculator, and this is the original one, function 991 Casio, which is being made by the Casio company. So you can order, just go to the descriptions of this video, click it, you will see the link that will take you into the actual descriptions of how you can order and what the cost, how can you, what the cost and what the guarantee we are giving you, because we should give you a guarantee, and we have to make sure that we protect the products that we are going to give you. So make sure that you do that in order to order this scientific calculator. We can ship in any regions of 31 regions of United Republic of Tanzania, including Zanzibar and including Unguja and Pemba. So right now we have so many departments in online undergraduate Polytechnic Institute of Tanzania. One of the departments is called the Higher Engineering and Scientific Mathematics. Well, so in these departments we are teaching first year students and second year students all about the beauty of higher engineering and scientific mathematics. And today we are teaching you a modular course called Calculus. In these departments we are going to teach you 12 courses or 12 modules, so stay connected. And we believe that all of those 12 courses or modules will help all the engineering students who are doing the year studies in Tanzania. We are using the curriculum of TCU, it means Tanzania Commission for Universities, and the curriculums of NACTE, that the long-term its long terms is National Council for Technical Education. So those are the curriculum because we should be focused. But remember, mathematics is universal, especially higher engineering mathematics and higher scientific mathematics. This is universal concept. So any student in any country, whether in China, whether in Europe, just in British or in UK, or possibly that some of the students who are learning these contents maybe in some of the small countries like in Serbia, etc. So you can learn these contents and harvest what we are going to share with you. Okay, so today we are in lecture 3, so the module of the course is called calculus. The class in most institutions, for example, the National Institute of Technology, this course is covered, or this module is covered in first year, or first semester of the first year, and this is B.Eng. Abbreviation Bachelor Engineering. And then this is lecture 3, problem solving of Fourier series, and I'd like just to do the quick review of lecture 2, what I told you. And then this is chapter 5, it is titled as just introductions of Fourier series. It's not a detail because in some of the engineering colleges or institutions, you find Fourier series, it's a module or it's a course. Okay, so let me take you inside. I will give you some other announcement later. So the quick review of lecture 2. In lecture 2, it has been titled that derivation, just to remind you, what I told you that I told you how you can do derivation of what? Of Fourier coefficients. Derivation of the formulas. Derivation of the formula of what? Formula of Fourier coefficients. Fourier coefficients. So we have 3 Fourier coefficients if you do remember. First of all, we have to remember the general formula of Fourier series. F(x) is equal to A naught plus what? Sigma notation from n is equal to 1 to infinity. And then we have what? A subscript of n. Then we have cosine of nx plus bn. Then we have sine of what? Nx, just like this. Okay. So that's the general formula. So then we derived that the first Fourier coefficient, which is A naught, is equal to, we can get it over the range from negative pi to pi, is 1 over 2 pi from an integral from negative pi to pi of what? Okay, so let me just do the final quick review and then we go into today's session. So I said that in lecture 2, I told you about the general Fourier series. This we call the general formula of Fourier series, which gives us f of x is equal to A naught plus summation from n is equal to 1 to infinity, and then we avoid an times cos of nx plus bn sine of nx. And then we have 3 Fourier coefficients: the first Fourier coefficient, the second Fourier coefficient, and the third Fourier coefficient. And when we'll be solving problems of Fourier series, we'll be finding the values of those, just the general formulas of those Fourier coefficients, and then we find the terms of the series, right? By substituting n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, etc., etc. So the first Fourier coefficient is A naught. We derive this formula that we say A naught is equal to 1 over 2 pi, integral from negative pi to pi, f of x dx. Okay, so we're integrating respect to dx. So this is over the range. Remember that we are dealing with Fourier series of periodic function of period 2 pi, right? So it means from negative pi to pi. That's what we are dealing with. We are still in the first subtopic that called the Fourier series of periodic functions of period 2 pi. Okay, so what? So then the second Fourier coefficient is A subscript of n is equal to 1 over pi, integral from negative pi to pi f of x times cosine of nx dx. Then the third Fourier coefficient is bn. This is equal to 1 over pi, integral from negative pi to pi f of x times sine of nx dx. Then I told you about even function. The mathematical even function is f of negative x is equal to f of x. Example of periodic even function is cosine of negative x is equal to cos of x. Then against that the odd function, f of negative x is equal to negative f of x. So the example is sine of negative x is equal to negative sine of x, and you are going to use them effectively. So today, before I take you into the problem of what the problem solving of Fourier series, I would like just to spend a few minutes just to give you some constant function, okay? Some constant function, all right? So some constant function, okay? So this is, we call them integrations of constant, integration of constant periodic function, right? Constant periodic function. So this is the general. So the first one, whenever we'll be integrating from whether it is defined integral or infinite integral, whenever we'll be integrating cosine of x dx, the answer will be sine of x. So because we have limit, we should introduce a limit, let's say from a to b. So here also we have a square bracket from a to b. So for that case, also we like just to give you the general terms. Whenever we integrate from a to b, the cosine of nx dx, the answer is equal to what? The answer is equal to sine, positive sine of nx over n. Then from a to b. We taught you in integrations how you can deal with this. For example, if you're getting cosine of 5x, so if integrating cosine of 5x dx, the answer is equal to cosine is equal to sine of 5x over 5, right? So I believe that you remember it. In case you forgot, just join me in other online schools, especially the online Tanzania online advanced secondary schools, where we teach you about integration. But you can go back into the online diploma Polytechnic Institute of Tanzania, square bracket OLENJOLAIM, where we are teaching the basics of calculus and the basics of differentiation, integrations, differential question, right? So you should not be disappointed. So then the third constant, whenever we are integrating what? We're integrating, let's say sine of what? Of nx, which is positive, dx. The answer, so from a to b, for instance, the answer, it will be negative cosine of what? Of x from a to b, right? From a to b. So that is if we're integrating. So if you're integrating positive sine x, sine nx, because sine of nx, so let's say sine of x, then the answer is this one. So you have to bear in mind. So because we are going to deal with odd and even function, it means that once we be integrating from a to b, sine of what? Nx dx, this is equal to integral from negative cos of nx over n from a to b. All right? That's the concept. This is a constant. So we should not waste our time to show how do we get, because we learn this stuff at basic engineering, mathematics, and basic scientific mathematics. So you just go straight forward. So then another constant interval of periodic function, it is in case will be given to integrate negative sine nx. Let me go straight forward, because this will be dealing with nx, maybe integrate negative sine of 2 pi x over L. So we have different cases. So from a to b, then the answer here is equal to what? This will be equal to cosine of nx. So the answer is equal to cosine of nx over n. Okay? From what? From a to b. So it will be positive. So you see the difference between the fifth constant periodic function, the integral of the fifth constant periodic function, and the third periodic function. So you see the difference here. That this is positive sign, this is negative sign. So you have to be careful when we'll be finding the sign function, because there is a change. If you'll be integrating, number 6, what if, I know that you're asking yourself a question, what if I will be given to integrate integral of negative cos nx dx? So the answer, it is negative sine of nx over n, okay, from what? From a to b. Again, we have to remind you, in case that you're going to integrate dx itself, right? So number 7. So in case we are integrating dx from a to b, simply this mathematics, we say that is integral from a to b, x power 0, dx, and the answer is equal to x, then limit from a to b. So those are the sum of of constantine. We call it constantine, the sum of the integral of constant periodic function that we are going to deal in this topic of Fourier series. So I believe that now you're in a good position. I would like to ask you, ladies and gentlemen, join me right now into the first problem that we have to solve in Fourier series, right? Fourier series. So you have to make sure that you copy it quickly, because I want to clean the blackboard so that I can give you some other material. So I believe that in case you have any question, don't hesitate to ask it in the comment section. We'll be trying our level best to answer the predictable question that most students used to ask in regular classes without even waiting them to ask it through our lectures. So if you'll be joining or learning with our lectures, you'll get answers of so many questions. But in case you have a special question, please, you can ask your question in the comment section. Okay? Okay. So right now, I would like just to take you into the next step that I want to present a problem. Remember that I told you that in most problems of Fourier series, you'll be tested on sketching the graph, okay, on sketching the graph, and also you'll be tested on what? You'll be tested on finding the Fourier coefficient. You'll be tested also finding the Fourier series. And you see that in this first example, we are going to have what? So in this first, is this the first example? Yes, this is the second example, because we left a homework for you to write possibly. Yes, I didn't leave actually that. They leave, yeah, it means it's the, yes, I gave example 1. So let us go to example 3. So don't worry about the number of examples. The issue is just understanding the concept. So this is example 6. This is example 3. So this is example 3. Example 3. And this example 3. Just you have to refer the book called which I mentioned in the general introduction, engineering mathematics. So it's called the higher engineering mathematics. So refer higher engineering mathematics. Okay, page 658, but also you can refer the final exam, the VAT final exam, the VAT final exam of 2018, question number 6, which had 10 marks. So the question state like this given. So write it quickly so that we are going to solve it together, because you are going to follow so many steps. Given f of x is the periodic function. So this is the periodic function. Okay, it's a periodic function defined as f of x is equal to curly bracket is equal to negative k when negative pi is less than x less than pi less than 0. Okay, so k then positive k from the interval from 0 less than x less than pi. Again, you've been told that the function is also periodically function. It's also periodically outside of given range. Outside of given range. So the given range is period of 2 pi. So then now, the first equation, which is Roman 1. So you've been asked to sketch the graph of the function f of x. Roman 2, find Fourier coefficients. Find Fourier coefficients. So it's plural. Then Roman 3, afterward, finally, find Fourier series. So for the final exams or university exams, or yes, because university exams or the annual exam, the students has been rewarded 10 marks. In most test-2 exams, you find these questions is given or is tested to the students so that to test their level of understanding. So, ladies and gentlemen of undergraduate engineering students or engineering programs, that the questions you are allowed, if you've understood and you know the principles of integrating trigonometrical function or products between the geometrical functions and polynomial functions, means of integration by parts, you can pause the video and then you solve that problem yourself on the graph paper. And then you come back and check the response or check the right solution so you can correct yourself and enjoy the beauty of higher engineering mathematics. Okay, so the big in these problems, we can break it. We are going to follow so many steps. So I believe that you have already copied. Okay, already copied the problem. So solution. This is solution. We'll be taking you. We are going to follow so many steps on solving this problem. So you have to be careful. The first step, we have to answer. We have to sketch. We have to answer Roman 1. Sketch the graph of what of the given function f of x. So how do we sketch? We are going to sketch it in xy plane. We're going to sketch it in xy plane. Okay. So let us sketch it quickly and then go to Roman 2 and Roman 3. This is the y-axis. Ladies and gentlemen, higher engineering mathematics and higher scientific mathematics is beautiful, so you have to enjoy, keep on enjoying. Okay, so this is x-axis, so this is y-axis, this is x-axis. So this is what? 0, 0. Okay. So again, we have some x coordinates. The first one is pi, the second one it is twice pi, the third one is 3 pi. Then we have again over the same interval, negative pi on the left hand side, negative 2 pi, and negative 3 pi. So what the positive value? So the positive value here is positive k. And then the negative value here, it's negative k. We don't know the value of k. K is just an arbitrary constant. It can take any value. K, it can be 3, it can be negative 3, it can be 4, it can be a half, it can be 0.5. So we don't know the value of k. So after having this one, then we go back to our function. What the name of this function? The given function is called it's called the composite function. It's a composite function because it has been made by the two sub-functions. The first function is this one. F of x is equal to negative k from negative pi to 0. F of x is equal to k when between the interval from 0 to pi. So it means we have two functions there which have been combined together. So let us take the first function. The first function begins from negative pi. When the value of x is negative pi, the value of y is negative k. So this is x-axis. So when the value of x is negative pi, then the value of y is what? The value of y is so let us do minor editing here. So this is negative k. Okay? So it means that this is not a dotted line, it's a full line. Let me draw it clearly. So it's a full line. Okay, so this is negative pi, and this is negative k. So when the value of x is negative pi, the value of y is equal to negative k. But again, when the value of x is equal to 0, the value of what? The value, so it means our first point is this one, our second point is this one. When x is equal to 0, value of y is equal to negative k. Then we are done with the first subfunction. The second subfunction, when x is equal to 0, the value of y is equal to positive what? K, simultaneously. Aha. So it means that we are going to have another point here, right? So we can join where we ended in the first line. So our first line was from here, just going to here. Then the value of x, when the value of x is equal to pi, the value of y is equal to k. So where is pi? So this is pi. So this is pi. So here we have a point. So we can join these two points like this. Okay, so but again, you've been given detailed information. The function is periodically outside the given range with periods of 40 to pi. What does it mean? It means that this is the periodic function now. It repeats. So how does it repeat? Let us start from the positive right hand side. So from positive right hand side, this function, so we can just extend like this. Okay, it means when x is equal to pi also, the value of y is equal to negative k. And also when x is equal to when x is equal to 2 pi, then the value of what? The value of the value of y is equal to what? Is equal to negative k. So let us sketch it clearly. Okay? So then we say when the value of 40, when the value of x is 2 pi, the value of k is negative what? Negative k. Then again, when the value of x is equal to 2 pi, okay? When the value of x is equal to 2 pi, then we say that this is the case. Okay, when the value of x is equal to 2 pi, the value of y is equal to 2k. Then we say that when the value of x is equal to 3 pi, the value of x is equal to 3 pi, okay, is equal to 3 pi, then the value of y is equal to what? Is equal to k. So this is the line joining. Okay? We can use dotted lines or you can use a full line. So it depends on your choice. So you can continue as long as you continue. So also this is continuous on this side. Okay? You can either use a dotted line to show that, especially for the non-periodic function, you'll see that you're going to use dotted line. So then the function goes this way, and then again it goes this way. So you see that the function also is periodic outside of the given range. So the given range is from negative pi to pi. Right? So I told you that you'll be tested. Many questions of Fourier series will be asking you to sketch. So let us label our figure as figure 3.1. So we have now, so remember that this is periodic function, it repeats. This is not the end of this function, so it means that again, you can find that it is still periodic, also this range. Also it is still periodic, also this range. So right now this is what 4 pi, and then just it is continuous. So it repeats infinity. That's what it means of periodic function. Okay? So now we have sketched. So if we've been given 10 marks right now, so with the sketch, you have 2 marks. Okay? You have 2 marks. Okay? So you have to understand, don't expect that maybe you have linear graphs or quadratic graphs as well as you know. This is periodic functions, very important functions in electronics and telecommunications and computer signaling. Right? Very important. We used to find this one. Okay, for example, that you can say this instead of writing k here, so you can write what you want. So this is 1, this is bit 0. So this is positive negative 1. Okay? Wow. So if that's the case, then we have to keep, we have to go for the second state. The second state, we have to answer the command 2. We have to find out the first Fourier coefficient. Okay, so to find the value or the general formula of first Fourier solution, so you recall the formula of what? Of A naught, which I taught you in lecture 2. Okay, so you say A naught is equal to 1 over 2 pi, then integral from negative pi to pi, then we say f of x dx. So we have to find it. So 1 over 2 pi, integral from negative pi to pi. What's our function? We have 2 functions. Okay, the first function, y is equal to negative k dx, then plus integral from negative pi to pi because it's composite function. Then you have positive what? Positive x, positive k, then dx. Right? So you have such kind of fortune of integral function. I believe that you're enjoying the beauty of higher engineering mathematics. Okay? So I believe that you enjoy the beauty of it. That engineering mathematics is so beautiful, scientific mathematics is so beautiful. And it's so beautiful. And it's true that it's so beautiful. I want to tell you, dear students. So then the next step now is just we have to use the basic principles of interpreting a constant number, which is k. Okay? So simply we say that A naught, this is equal to what? So k is common, so I can take k outside of the bracket, 2 pi, and then we have what? The integral from negative pi to pi of what? Negative dx, then plus what? Integral from negative pi to pi of what? Positive dx. So, if this is the case, we say that that is fine. Then, so you have to remember that. I told you a few minutes ago that if you integrate the x, what do you get? So this will make k over 2 pi. So if we integrate this one, integrate negative x, we get what? Because remember that here it is actually integrating negative x power 0 because x power 0 is 1. And also here we have x power 0 is 1. So if that's the case, you have x power 0 plus 1 of what? 0 plus 1 by using the laws of integrals, then negative pi to pi plus what? Integral. Then we have what? We have x power 0 plus 1 over 0 plus 1. Then limits from negative pi to pi. Okay, so then we close the curly bracket. So a naught is equal to k over 2 pi. Then we have this curly bracket. So 0 plus 1 is x, 0 plus 1, no, 0 plus 1 is 1, 0 plus 1 is 1. So here we are going to get x from negative pi to pi. And then we say that what? But this is negative, remember, it's negative. Okay, negative. So then we say plus what? Here also remaining is x from negative pi to pi. For the students who love shortcuts in mathematics, so you can just, we used to teach them that when you're integrating the x's, simply cancel this integral sign with this d, the answer is equal to x. But this is special for the students who like shortcuts of solving problems in mathematics. Right? So cancel d with the integral sign, the answer is equal to x. Okay? So a naught is equal to what? K over what? Over 2 pi. So then here we have what? Substitute pi, it is negative pi. Minus what? Negative pi. Plus what? So here we have what? We have pi. Minus what? Negative pi. Okay? So then we close the curly bracket. So negative times negative pi. Negative times negative, we get positive. So negative times negative, we get positive. To find the first Fourier coefficient, we know it's very simple, but you have to be careful because this is it's analytical work, but it's kind of algebraic work. You have to be careful. So a naught, ladies and gentlemen, is equal to k over 2 pi. Then here we have negative pi. Negative times negative is positive pi. Okay, positive pi. Then plus. Then here we have what? We have pi plus what? Negative is positive, like this one. So then we say that we have a naught is equal to k over 2 pi. Right? So negative pi plus pi, this is 0. And then plus what? Pi plus pi is twice pi. So twice pi plus 0 is twice pi. So a naught is equal to what? 2 pi k over 2 pi. Okay, so listen, I made a mistake here. And the mistake is this one. I substituted pi in x, so negative x, so I got negative pi. So then minus negative is negative, so this will be positive. Right, this will be positive pi because negative pi times negative x, it is positive pi. So if that the case, means this also it is what? It's negative because negative times positive is negative. So for that case, here we won't have 0. We are going to have what? We are going to have negative what? 2 pi. Negative 2 pi. So when you take negative 2 pi plus 2 pi, the answer is equal to what? 0. So 0 times k is equal to 0 over 2 pi is equal to 0. So a naught is equal to 0. So our first Fourier coefficient, the value of our first Fourier coefficient is 0. Wonderful. So my students, they used to say that, sir, if I could know, why? So it means that I bothered myself on finding the value for 0. If I could know that, I could write and then do some maneuvers quickly until I get 0. But that is illegal. The third step. For the third step, we say that recall the formula of what? The formula of AN. So we have to find the an. So an is equal to 1 over pi, integral from negative pi to pi. Then we have a function f of x, then we have cosine of nx dx. So that's the formula. Okay, so you can pause the video and then follow the same procedures that I taught. Remember the constant integral periodic function, especially the trigonometric periodic function, and then you can solve the problem on the rough paper before you watch my solution. And then so you come back and check my solution, and hence you enjoy the beauty of higher engineering mathematics, higher engineering mathematics and higher scientific mathematics. So we have this formula. What is f of x? Remember, f of x, it's a composite function which contains that when y is equal to negative k, the domains is from 0 to pi, from negative pi to 0. When y is equal to positive k, the domain is from 0 to pi. Okay? So then we say that an is equal to 1 over 2 pi, 1 over pi, not 2 pi, then curly brackets, so integral from negative pi to pi. The first f of x, it is negative k cosine of nx dx plus integral from where? From negative pi to pi of what? Of positive k cosine of nx dx. Alright? So we have to check the common term. So the common term is what? Is k. So we have k here over pi. Then we have what? So we integrate from negative pi to pi, negative cosine of nx dx. Then plus integral from negative pi to pi. Then we have what? Positive cosine of nx dx. Okay, so you have to remember the integral that I told you. So we say that this is the first step. So first step, we have that recall the constant integrals that I told you that if you're integrating cos of nx dx, the answer is positive sine of nx over nx. But also, if you're integrating negative cos of nx, the answer is equal to negative sine of nx over n, not the nx over n. So if that's the case, you say that we have an is equal to what? Is equal to k over pi. So when we integrate this function, we get what? Negative sine of nx over n. Then limits from negative pi to pi plus, then once we integrate that, we get sine of nx over n from what? From negative pi to pi, then we close the curly bracket. Okay, so if that's the case, you say that this is good. So we have that expression. So then the next, what the common term? The common term there, it is what? N. So you have to take n outside of the bracket. So you have k over n pi, then open the curly bracket. Then now we substitute the limits. So whenever we have x, we substitute with pi and negative pi. So for this case, we have negative sine of 40 n pi minus the normal one, what? Minus negative sine of negative pi n, or negative, we call it n pi. Okay, so then this here we have a square bracket plus what? So you can have a square bracket. Here we have sine of n pi minus what? Sine of negative pi n. Negative pi what? N. So ladies and gentlemen, so here we have to record we have to go diffuse state. So the diffuse state, we say that because we have sine, recall that for all the function, which I told you, for all the function, f negative x is equal to negative of f of x. So it means whenever we find sine of negative pi, this is equal to negative sine of n pi, right? You remember that the concepts of all the function I told you in lecture 2. So if that's the case now, ladies and gentlemen, we have an is equal to what? Is equal to k over n pi, and then we open the curly bracket. So then here we have the square bracket, negative sine of what? Of n pi. Then we have negative, so negative is negative to be positive, positive times negative to be negative. So minus what? Sine of n pi. Okay, then plus what? Plus sine of n pi. So then minus what? So negative is negative to be positive. So plus what? Sine of n pi. So then we close the curly bracket. So we check. So negative sine n pi minus sine n pi. So it will make your negative 2 sine n pi. Then sine n pi plus sine n pi will make your positive 2 sine n pi. So simply, negative sine n pi will cancel with positive sine n pi. Wonderful. Then secondly, the negative sine n pi will cancel with positive sine n pi. Okay? So simply, we take that, what do we have? So we have the an is equal to k over n pi multiplied by 0. Because negative sine n pi plus sine n pi is equal to 0. Negative sine n pi plus sine n pi is equal to 0. So 0 plus 0 is equal to 0. Wonderful. You see the beauty of mathematics. So an for this case is equal to 0. Oh! So the second Fourier coefficient an now, it gave us the value 40 of 0. Wonderful. So if I could be you right now, I have to stop to pause the video, and then I try my level best to find the Bn by following the steps that Sir Olenjolai taught me in finding the An, and then I come back and check the answer that I've got, so that I have to enjoy what? Remember, we are still answering example 3, Roman 2, finding the Fourier coefficient. We found the first one, the first Fourier coefficient, A0 is equal to 0. And now the second Fourier coefficient, generally, the An is equal to 0 also. So what else? We have to go to the sixth step, ladies and gentlemen. So the sixth step, we have to find the Bn. So to find the Bn, we have to recall first of all, it's the formula. So recall formula of what? Of Bn. So the formula of Bn is equal to 1 over pi, from negative pi to pi. Then we have f of x sine of nx dx. Okay, so if that's the case, we say that, okay, we have our function. Our function is composite function. When f of x is equal to negative k, its domain is from negative pi to 0. When f of x is equal to positive k, its domain is from 0 to positive pi. Wonderful. So now, ladies and gentlemen, we have bn is equal to 1 over pi. Then we have integral from negative pi to pi. Our f of x is negative k. Then we have sine of 40 of nx dx plus integral. Excuse me, this is from negative pi to 0. Then from integral, then this is from 0 to pi. And excuse me, excuse me, I'm very sorry. This is from negative pi to 0, and this is from 0 to pi. So let me do the correction. Excuse me, I'm sorry, I did a mistake there on the limits, on the lower and upper interval. So this is from negative pi to 0, and this is from 0 to pi. Okay? So then, after we call it, so here the lower limits is negative pi, the upper limits is 0. Here the lower limits is 0, 40 pi. Then, here we are. So it means that here we have what? N times 0, which is equal to 0. And then minus 40, that's everything is correct. And there we have what is sine of n pi minus what? Minus what? Minus pi minus n times 0. Right? Then we call for the odd functions and even functions. Okay, wonderful. So simply, this is not true. So here, this is not true at all. The answer is true, but the approach is not true. So we have negative sine of 0. Sine of 0 is 0. Sine of 90 is 1. So sine of 0 is 0. Then we have negative is negative, is positive. Positive is negative minus what? Minus sine of n pi. Then plus what? Plus sine of 40 of n pi. Then minus sine of 0 to 0. So close the curly bracket. So here we have negative sine n pi plus sine n pi is equal to 0. So that's why we say an is equal to 0. So we made a mistake, but the answer is still the same. But we did it wrong in case of what we deviated from the truth. That's why we have to do that correction. Because I know some other students say that, sir, you could just ignore. No, that's not true. The range for the first composite function is from negative pi to 0. The range for the second composite function from 0 to pi. So for this state now, we don't make a mistake. So this is k. Remember that we learn mathematics by doing mistakes. Okay, what I'm teaching right now is almost 80% of the mistake I did myself when I was in undergraduate level. Wonderful, 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 ladies and gentlemen, wonderful. Okay. Okay, so what the constant term there is k. So bn, so take k out, k over pi. Then we have the curly bracket, integral from negative pi to 0. Then sine, should not worry. Higher engineering mathematics is beautiful. It's your best friend, believe me, from 0 to pi. Then this is sine of nx dx as a curly bracket. So we go for the OT for the seventh step. The seventh step you have to recall. So recall what? Recall the concepts I told you that integrations of 40, periodic function. So the integration of periodic function, here we have a periodic function which is called the sine of nx dx. So it is positive. So I told you that its integral is negative. The answer is negative cos nx over n. So that's what we have here, but here we still have negative. So that is for the positive. For the negative, I told you that integral of negative sign nxe dx. This is equal to what? Positive cos nxe over t over n. Wonderful. So bn is equal to what? Is equal to k over pi. Then open the curly bracket, integral from negative pi to 0. Then we have what? So we should not write this one because you have to integrate. I've given you the principle there, so you have to apply. So this one, if you integrate it, we get what? We get cosine of nxe over n. From what? From negative pi to 0. And here we are, plus what? Plus negative, because we're integrating positive, because nx over n. You're allowed to speak when you are following my lectures, because when you speak, you are speaking the truth. It means you are absorbing this material. What the constant term there? The constant term is m. So this is equal to k over n pi. So you have the curly bracket. So now we can substitute the limits. Cos of n times 0 is cos of 0 minus what? Minus cos of what? Cos of negative n pi 10. So this is square bracket plus what? Negative cos of n pi, then minus, so minus negative cos of 0. Then we close the curly bracket. So simply say that the Bn is equal to what? K over n pi. Curly bracket. Before you substitute your limits, I want to write something in your mind which should be there according to my observations, because I've been teaching this topic for 7 years physically for undergraduate students of the first year Dar es Salaam Institute of Technology. So I've taught them I've taught them the BING 15, I've taught BING 15 this concept, BING 15, BING 16, BING 17, BING 18, BING 19, BING 20. Right? So 6. So now this is the 7th year I'm teaching this. So according to my experience of solving problems of Fourier series, once you find the first Fourier coefficient A0 is 0, and the second Fourier coefficient An is 0, you have to make sure that the third Fourier coefficient Bn should not be equal to 0. Why? Because we won't have any Fourier series at all. And to be wrong, because the graph showed that the function is periodic. So if it's periodic, then we can apply the Fourier function to find the components or the constituents of that series, of the given function, or of the given function that we drew its graph, and we have to find its step. So once you are doing simplifications, whenever you are doing or you are solving problems of Fourier series, and then you find A0 is 0, An is 0, Bn is 0, I want to tell you that don't collect that answer because it's completely wrong. Go back and check where you have made mistake. Possibly you have made some mistake in An, or you have made some mistake in Bn. Right? Okay. So cos of 0 is 1. Okay, 1. Then here we have minus what? Cosine of negative pi n plus what? Plus, so positive times negative is minus cosine of what? Cosine of n pi. Hence negative is positive. Cos of 0 is 1. Okay? It's 1. So ladies and gentlemen, enjoy the beauty of higher engineering mathematics. Again, I want to invite you, in case you feel from your heart, you want to offer our Father who is in our God, your free willing sense-giving offering in order to support the running cost for this program, because we could have paid a lot of money for you to get this stuff or these materials. Okay, but no, our Father or our God is a wonderful God. He has paid for you. Okay, and this is the gift for the Tanzanians of undergraduate students in Tanzania who are doing engineering and science courses. All right? So then we say that here we have the Bn is equal to what? The Bn is equal to k over n pi, and then you say what? We have 1 minus cos of 40 n pi, then minus cos of 40 n pi, then plus 1. Alright? But there we have cos of negative n pi. So you go for the 8th step. The 8th step, you have to recall about even function. The even function says that f of negative x is equal to f of x. And the example of even periodic function is cosine. So cosine of negative n pi, simply this is equal to positive cos n pi. So for that case, we have Bn is equal to what? K over n pi, okay, n pi, then 1 plus 1 is 2. Then there we are going to have cos of 40 n pi, then minus cos of 40 n pi. So cos of n pi minus cos of n pi, that will make what? So that will make what? That will make so it will make, so the Fourier coefficient Bn so the Fourier coefficient Bn is equal to k over n pi, then we have 2 minus twice cosine of n pi. So 2 is common. So the Bn is equal to twice k n pi, then we have 1 minus cosine of n pi. Okay, so then let us derive from 1, 2. And then we have to end this session or this lecture 2. We have to meet in lecture 3, when I will take you the next step of finding the Fourier series. So continue with example 3, and I'll teach you how I can find the Fourier series. So we say that in Roman 2, therefore, the Fourier coefficients are A naught is equal to 0, An is equal to 0, and Bn is equal to what? 2k of what? Over n pi. Then you have what? 1 minus cos of n pi. So this is the response that you're required to state. Okay, so let me leave the homework for you. So this is homework 3. So the homework 3 is Roman 3. So homework 3, we say that refer example 3, Roman 3. So Roman 3, you know now the Fourier coefficients. So it means that we ask you to find the Fourier series. Fourier series of 40 of f of x. So that's your homework. Make sure that you do it and submit your homework in the comment section. Okay, so wonderful. So I left out the homework because we have to do some few maneuvers there in order to get the entire series of the given function. So this is the end of lecture 3. I thank God who have been with me, who have created me firstly in his own image and likeness. I give him all the glory and all the honor. And also I thank you who have taken your times to join me from the beginnings of this session to the end. I really appreciate and I congratulate you for your decision. And may God bless you abundantly on your decisions, because actually you have done a great decision. And I thank God also you have built the teaching gifting in my heart, in my soul, in my flesh, because I am the teaching and teaching is me. So I really thank God who have given me also this national and international idea of teaching by using the digital platform. I'm sorry possibly that some of the words are not thin. I'll be trying my level best to I always try my level best, and I will keep on trying my level best to do modifications and to improve the quality of the video. So I believe in lecture 4, lecture 5, lecture 6, lecture 7, you are going to have a high definition video of actual acceptable high definition contents. So in case you have any question, ask in the comment section. We'd like to invite you also to offer your free will in Thanksgiving, to give, it means that you have to offer your free will in Thanksgiving to our Father who is in heaven, our own God, our mighty God. And then you can offer it by using the telephone number. This is the telephone number, 0759 345331. And then you have free will in Thanksgivings of any amount and of any type of the offering that written in the Bible will be accepted with much thanks from God, and also it will be used on the running cost of this program, so that so many lectures lecture videos of more than 500 will be posted online without charging students an amount of money, so that every student is going to take advantage and reduce the pressure and even reduce all kinds of the stresses of having supplemental absconding or discontinuity because of failure, or because of your failure of a modules or of a particular modules or course of higher engineering mathematics or higher scientific mathematics. So may God bless you abundantly. I'm always praying for all my online students. I ask you also to pray for me. I invite you in the lecture 4, because that is lecture 3. The lecture 4 where I will be teaching you against, I'll take you the next step of problem solving of Fourier series. Possibly that lecture 4 and 5 will be solving problems, because you know in exams we'll be asking problems. So I have prepared a number of problems that will give you clear understanding of Fourier series. So may God bless you until we meet.